Hello, my name is Dmitrii. Hello, my name is Dmitrii Misharov, and this talk will be about OpenSSL and hardware bucket keys and PKCS 11. So it's not deep cryptographic talk. It's mostly about my hands-on experience with all these pieces, how they set up, configure, and work together. By the way, I work in OpenSSL Corporation, so I, especially want to emphasize that how this works with OpenSSL. So, what about the private keys and how do you need hardware bucket keys? Usually, how we work with the cryptographic material, we, generate the key, for example, with OpenSSL. It's stored on a file system on some machine and some host. And we just use them for cryptographic operations, encrypting or signing. This is simple, it's common, it's nothing wrong with that, we just can use it. But sometimes it's just not enough, especially when your key material and operations really need to care about how to handle this. And you need a special handling of that. So how classically OpenSSL handles the keys. We just store it somewhere on the file system, on the operating system. We specify the path, and OpenSSL loads into software or into memory, and it's signing, and some encrypting happens in the. And yes, it will happen in the process. As I said, it's easy, it's common, but not always desirable. And here's the simplest example how we do the signing with OpenSSL. We specify the digest, specify in the sign argument the path to private key, and other parameters, just what you want to sign and where to store the signature. That's simple. It's an example which I will later show how it will use with external keys. So when the file-based keys, is not enough, when you have specific requirements for compliance, such as PSI, DSS, FIPS, and so on, and there is a key theft risk, especially when you work with in a shared infrastructure, and sometimes when you need audit and access control to the key material, and everything you need to care about, then file-based keys is not enough. And for these such cases, enters HSMs. HSMs, it's a hardware security modules. It's a dedicated cryptographic device. And the main purpose of it is protect key material. So it will not export it and not exposed. And it performs cryptographic operations on behalf of the software, but often the key material is not exportable and is not exposed. So there are some, tampering and defense and some audit access control. So a lot of operation stuff is done around protecting the key material. This is very important in specific environments, which needs to be cared with these devices. This device I really had experience with. It's a network-attached HSM from Nshield 5C. As you see, that's a rack unit module. It's put into your rack cabinet. It's very noisy, it's very powerful, but the main reason is, just generate random numbers and protect your key material. So it has a lot of sensors. So, for example, if it just cannot tamper it, open the rack, it will be immediately alarm. And the main reason of it is just protect the key material and provide access and audit control for that. Yeah, so we have at OpenSSL Corporation, we have two of them. We do some cryptographic operations for that, and this device I will work with that, and that's my talk dedicated about it. So how usually, we want to talk this software with hardware. So each vendor, HSM vendor is different. each of them have its own terminology, software, infrastructure, and ecosystem. Obviously, software like cryptographic software or some software which need cryptographic operations to perform cannot adapt to each vendor. So we need some standard APIs, a standard interface to talk to this kind of hardware. And this standard exists. It's called PKCS 11. It's a standard C API for cryptographic tokens. It defines keys, sessions, objects, and it lets software use keys without accessing them directly, into the file system. And PKCS means public key cryptographic standards. It's a family of crypto standards. So number 11 means the same as RFC, for example. So it's not a version, it's just one of the standards from PKCS family. So there are PKCS 1, 8, 7, and so on. Originally, it was created by RSA Laboratories in 1994. So it's old standard. But it's still maintained, it's still evolved and heavily used. It's still nowadays, but mostly now with HSMs. And work continues at organizations called OASIS. And there are many counterparts presented in OASIS technical committee, involving some OpenSSL representatives and others industry representatives. So the standard is still alive and still heavily, actively used and maintained. Original purpose was 1994 smart cards, tokens, security devices. So that's why this terminology still sounds like old-fashioned. And nowadays we mostly face this standard using via HSMs. And now this terminology mostly used as abstractions on vendor-specific devices. But still, we actively and widely use this in this standard. So how to think about PKCS 11? So application never sees private keys. It just only asks about doing some performing cryptographic operations, sign this, encrypt that. And vendor PKCS 11 library talks to device and does this operation. And how OpenSSL fits into this picture? OpenSSL provides cryptographic operations and key material, in case of HSM, live somewhere else, but we still need to talk to HSM, and we need some bridge, between providers implementation and our cryptographic library. So PKCS 11 is one of these bridge. And the core of this, talk, that's how all the things work together. So there is a layered diagram, how that end user and endpoint application, which want to perform some cryptographic operations, will actually finally talks to HSM. So we ask OpenSSL do some cryptographic operation. After that, OpenSSL talks to provider engine, which implements bridge to PKCS 11 module, and that vendor C API implementation from that, for example, Shield does the specific operation, and it goes back from that layer. So this is the complicated thing, but that's how we work with PKCS 11. It needs to be mentioned that how OpenSSL implements this extension of the bridge. So since OpenSSL 1, there was a mechanism to extend OpenSSL. It's called engines. So nowadays, it's a legacy way to extend OpenSSL, and recommended and only will be used way is called providers. In upcoming OpenSSL 4 release, engines removed completely. So if you will ever use some PKCS extension, just use providers, don't stick with engines. But for older versions, it's still okay to use it, but PKCS 11 provider is the thing which we will use, and I will talk about in this talk. Yeah. So what is PKCS 11 provider? So as I said, this is a special model, bridge between OpenSSL and vendor PKCS 11 implementation. It is open source project. It's part of the OpenSSL project family. So if you might know that OpenSSL library is not the only project from our organization, but we have plenty of them, and PKCS 11 provider is one of them. It lives and is linked on GitHub with OpenSSL project organization. Yeah, so to use it, you need to specify it in the configuration and provide that cryptographic operation onto them. It needs to be mentioned that limitations when you work with PKCS 11 in OpenSSL. For file-based keys, you can generate the key, do some other lifecycle management with it. But when you work with HSMs in PKCS 11, OpenSSL just can use only existing keys. So for any lifecycle management, you have to use vendor tools. So for each vendor it's different, and OpenSSL just use that. It can give a PKCS 11 provider. And this is the same OpenSSL sign-in command, but in the PKCS 11 context. Yeah, we specified the configuration for OpenSSL. Later we will show you how it looks like. And instead of providing the path in sign argument, we're providing so-called PKCS 11 URI, and we're specify the token, object, all this, reference to the key in PKCS 11 context. Yeah, this URI is not OpenSSL invention. It's also standardized. There is RFC for that, and you have to learn also how to use this. And other parts of the command is the same. It might ask you to provide, enter the PIN or password for your key. It depends how you protect your key, but yeah, it's also out of the bit context. So it's on the really simplification. When you start to work in it, you will have a lot of corner cases around that. This is the excerpt with the OpenSSL configuration. This is also shows that you need both for working with HSMs and PKCS 11. You need path actually for PKCS 11 provider that underline module. This actually is installed using your favorite package manager in your Linux system as a PKCS 11 provider, and then just provide the path to that module. And the PKCS 11 module path, it's specifically path for the vendor implementation. This is the example from Enshield 5C. So they see this is a module, and you need to specify that, and only after that, all the pieces will work and fit together. It needs to be mentioned that if you work with PKCS 11, you need also another tool if you want to figure out how your keys represented with that context. There is another very useful tool. It's called PKCS 11 tool. It's from another organization. It's called Open Smart Card, OpenSC, and it's very useful for debugging, introspection. And if OpenSSL doesn't work with that, please start to look firstly into this utility. It's very helpful, and I use it a lot. And for example, to list in some token slots, reading objects, and so on. So it's very useful, and it's used for tests and debugging. Yeah, also, as I said, you need plenty of tools, and PKCS 11 also doesn't replace HSM vendoring. It's only work with what a limited PKCS 11 context. So it doesn't work with the keys and that cannot generate it and do any lifecycle management. But still, without that, vendor tool cannot work with PKCS 11 in context. OpenSSL cannot do also that. So you need all the things all together to work with that. And this is example for this PKCS 11 tool output. I will not go through all this, just to show that if you want to enumerate slots, you just provide the command, and it shows you some slots, but they're not real slots. It's just abstraction. It's how a vendor represents its own objects via PKCS 11 tool. You still need to use it if you want to understand how your objects are represented within it. So what surprised me mostly when during HSM setup, that it's not algorithms and cryptography and some this complicated stuff. Mostly was really how that setup, configure operations around that is very requires some discipline and for planning how to think about it before you will start doing something in production, especially backup and recovery, which I will talk about later. You need to be very careful with that because the keys are not exportable. You still need to think about it, how to work with them. Of course, each vendor has its own tooling, its own terminology, ecosystem. So for each vendor, you need to learn what they mean by some terminology. Yeah. For example, that my experience with backing up and recovery. Yeah, as I said, non-exportable keys doesn't mean that you can back it up or recovery. You just need to think about that. It's just how vendor represent this key material. In case of Shield and Trust, they store the key material on some client on Linux host, but it's not readable. Yeah, it's encrypted, and it works only within so-called security world. It's another vendor terminology. And to work with security world, you need to work in HSMs. I mean, to back up key material, you can do that, but to restore it, you need function and security world and provide quorum cards. So a lot of operations, a lot of stuff you need to learn and to work with HSMs. It's really complicated stuff, but sometimes it's really, you have to use it. And takeaways from this experience, that OpenSSL can use external keys. It requires a specific module bridge to talk with HSM devices. It's called PKCS 11 provider. It started as a token interface, but still this standard interface is evolving and maintained. And vendor modules, requires to be learned because each vendor is very its own world, own ecosystem. And it's mostly that's it I wanted to talk about today. And if you have any questions. Yeah.
How many vendors support this, the HSM vendors, and maybe is it still applicable to smart cards or something else?
Yeah, so as I said, PKCS elements wide standard. Usually, if the vendor wants to, be work with some tools, they usually implement PKCS 11 standard in some way. So I would say most of the vendors, HSM providers, makes this PKCS 11 implementation. They later, depends on your software, how to use it. In terms of OpenSSL, you need to use PKCS provider. And without that, you have to, adapt your software and use specific APIs from that HSM vendor. I'm sorry, I didn't understand.
Okay, so thank you very much for the presentation.
Yeah.